I am doing a Fusion 360 Update Your Feeds and Speeds version 2 as I learn more and more how to use the tool library better. This has been a big leap in even my own learning here and try to get all this stuff to be automated. Even though I was a hand programmer, so off the top of my head I kind of knew if I putting in hard numbers what I could come up with. But I try to use the built-in tools that do some self-calculations. But I've actually taken it to another step to actually help myself out, and it made it easier in class. I tried to do it as a feed and speed lesson, which is kind of more advanced. But this will give you basic feeds and speeds, because if we're doing Titans of CNC tutorials, he's really just telling you RPM and feed rates without explanation. Because it's a different subject. So if we just give out feeds and speeds that are kind of like machine specific for whatever machine you're on, this will get you light years ahead, and then we can learn to improve on it. So I was looking at other videos, tool library improvements. At first, I always hate change, but I learned to really like this one. In Fusion, I always disliked. Oh, I must have closed Fusion down. That they had separate ramp and spindle speeds, because it meant I had to hand type a lot of stuff. But I've actually made it, I use it to my advantage now to put all this preset cutting data. So if you look down the bottom here, it just says preset cutting data right here. And I actually discovered it sort of by accident when I downloaded a Haas tooling library, because I saw they had tools and I thought I just would build my library that way into something more current versus the older Fusion library, the sample library that used to be installed. Now when I was in that library, let me pull up a part here. I have a Titan 1M here. I have one that I have not done setup sample. Alright, so I have no camera manufacturer stuff. I just have setup only, and actually I have a face mill only. So normally we would have gone, if we do it the Titan method, we do adaptive clearing, and then we go in and select a tool, and we go to our Titan library, which would be in this old library here, and pick like a 3/8 end mill, and then hit this, and we would have hand typed in all these and updated them. And then we never knew kind of what to do with this area here, this optimal load and all that stuff. So now I was able to update my feed and speeds and also calculate step over and stuff like that. So let's go back to 3D adaptive, select, and this is the Haas tooling one. And I went in here and said, oh, look at all the nice tools. I can just do like flat end mill only. I can sort by size, like 3/8. I got 4 flute, 5 flute. There's an aluminum one, 3 flute. That would be pretty good. And then I saw this stuff. Like, ooh, what's all this data? Ooh, non-ferrous slot milling. These are really high RPMs. What are? Oh, this has got all different data in here. Okay. Non-ferrous side milling. All right. Hit select. The RPMs are way high. So, but that's okay. It still means I got to tweak things. So I would look in there and say, what the heck is that stuff? Let me go in there and look. Haas tooling 3/8. What is this stuff? Let me open up that tool. All right, I got cutter. Yeah, I got shaft holder, cutting data. I started looking down the list here and going, oh. And I started learning about user parameters, these FX numbers. So I got because I would like to update just by feet per minute. So if I was in here, I go back to the 3D adaptive, select Haas. We'll just wing it with the Haas one here. 3/8 flute. I'm just going to pick this one, hit select, and I go here and go, okay, I want to use 1,000 surface feet per minute, right? And it updated both. And this, if I had a 12,000 RPM machine, this would be great. Down here, I don't know what the original feed rate was. Let me go back to, I learned how to do this one, non-ferrous, 2.7 thou per tooth. So if I made this 1,000, and it forced the feed per tooth to be different. So I'm going to change that to 0.0027, and it updated cutting feed rate, lead in, lead out. This is kind of where I wanted to get to. And then my ramp in almost too many feed rates, but that's 270. Can I just change this one? I'll just pick 3, and that's pretty good. So I was able to do that by just doing surface feed per minute and feed per tooth and feed per rev calculations. But I'm still based on whatever numbers we're defaulting over here. So where are they getting those numbers from? I didn't stick with that operation. Let's go back to the Haas tooling and go back to the 3/8. And let's see, there's a lot of data in here. Let's see, N2 side milling. Let's go back into the tool itself, cutting data, N2 side milling. And down here it has step down and step over. And use coolant, and vertical feed rate. So all your stuff right here, these are user parameters. So if you update this, it should show what it's related to. Tool feed cutting. Okay. Hello, Sydney. Right. So what I decided to do is building my own library. So I got my milling tools, right? The same basic library, flat end mill. I have 1, 2, 3, 4 tools. I got default, and I started to add in these like adaptive 30%. I want to go in here and look at what do I have. We have description, cutter, holder, cutting data, and also in post-processor, while I'm at it, I add this in here so it ends up in my G-code at every tool change. I liked having that if I'm in the middle of the program hunting around. Cutting data, I got all these presets here. I actually don't even need this one. So I can actually remove that one and just keep these. This is one I just added in. So I had adaptive pocket, which is different than, that's the old way of roughing and finishing, but pocket we've been using for a nice floor. And contour. So I have adapt, this is like a 30% of tool diameter, and that means right here, step over. Step over is going to be the optimal load in Fusion, which is the 4th tab. And I already have the RPM spelled out because this is the highest RPM of the slowest machine. So it'll work on either machine, but this will give you a much better starting point. These RPMs match, feed per rev, these are all good numbers in here. And these numbers here, passes and linking, use step down, use step over. So that means if we go to, like, let's do 2D adaptive here, select building block aluminum, 3/8. I'm going to use the 30% setting. And right there, it's right there. Now if I forget to do that, I can reselect it here. This is pretty much done. I don't have to touch this. if I was doing a project that I'm not sure what tools to use, I'm just going to select on the fly. If I wanted to go, the heck with it, I'm going to go 1/4 inch end mill. I think we have one in here. Flat end mill. Where the heck they go? Oh, I'm in the wrong one. Building block. 1/4 inch. I'm going to go lighter load, 20%. Hit select. It's all right there. 2D adaptive, which means I got to select geometry. Let's see. Contour selected. Pocket recognition. Ooh, it must be new. Let's see. Stock contours. No, that's identified. Rest machining. We need that. Heights. I'm going to leave that alone for now. And right up here is